It's already been announced, and I'm going to talk about 4 projects that my office and I are working on around the world, or have worked on around the world, tall buildings. It's a kind of club which you're all members of, and I'm aspiring member of the High Rise Club. What interests me is the geometry and form of high-rise buildings. And you've heard discussions over the past couple of days about different projects. And the first one I'm going to talk about is not far from here, just across the way, the West Tower in Guangzhou. And I guess what's each of these 4 projects is very different because the context is very different, and in fact the brief is different. So that gives us the opportunity to explore something new every time. So let me see if I can work the system. Yeah. Guangzhou IFC. Actually, in 2005, we won a competition for twin towers. You saw it in the previous imagery. And we got appointed, I should say we won it with Arabs. It was a joint venture because we were a fairly small practice and we hadn't done high-rise, let alone super high-rise. And we were appointed in 2005 for the West Tower, which is just under 440 meters high, which for us is tall. By your standards is medium, I guess. But at the time, it would have been one of the tallest buildings in the world. And it wasn't just a tower. It was 4.5 million square feet of accommodation, the usual sort of mixed use, typically office, hotel, shopping centre, conference centre, and residential apartments as well. So it was a voyage of discovery, and very exciting for us to be involved in such a project. One of the things that we do, Wilkinson Eyre, we're very interested in structure, and we work very closely with our engineers. And we were a bit concerned that having the hotel on the top, and there had already been 1 or 2 high-rise hotels, we were worried that the earth would move when you get into bed. And it worried me a lot, that, and I wanted it to be very stiff and stable. And working, since we hadn't designed a super high-rise before, we could start from the basics. Working with the Arab team, they came up with the idea of a diagrid structure, which is very stiff. There's also typhoons, as we've been experiencing here, which can have incredible wind forces. And we're in a seismic region as well. So there are a lot of things to consider in terms of the structure. And so we ended up with that diagrid structure, which is very stiff. And I'll talk a little bit more about it. But just to look at the geometry of our tower, I mean, we were looking for an elegant simplicity. That was the sort of starting point and the discussion during the competition. And of course, we're exploring new computer modeling techniques at the time, parametric, starting to do parametric. We ended up with this trochoidal shape, a curved triangle, which looks very simple, but is actually very complicated because each of the 3 facades are constructed on a radius of 5.1 kilometers. Now, it sounds an odd figure, and it's derived simply from modeling. We did a lot of physical models and computer models, and that's how it works. And the curved corners, The sides of each face are 71-meter radius, and the corners are actually a 9-point-something-meter radius. So it's quite a complex geometry when you look at it all the way up. And we were interested in how the diagrid would look, how to make it node out in the right places. So this is one of our drawings showing the sort of content of the inside of the frame, if you like. But there was a talk about making us face the Pearl River. Actually, with a curved triangle, we were more interested in wind forces, and we did a lot of wind tunnel testing, and the setting out of the triangle was adjusted to suit the wind pressure. It saved 20% on, gave more 20% efficiency on the structure to face in the direction we're in. So it has views in all directions and not just exclusively of the Pearl River. So I'm not going to go through all the details of the structure, and I hope you won't ask me detailed questions because I'm not very good on detail generally, but just our concept of the diagrid, we wanted to make the most out of it, so we wanted to express it as part of the architecture. And if we look at the GAs here, you can see the elevation on your left. The section shows what the diagrid can actually do for us, because it allowed us to have an atrium on the top 30-odd floors for the hotel. So the building actually is fattest a third of the way up, and it reduces to its thinnest at the top, which is where the hotel is, and it's single-sided rooms around an atrium. So that was how we developed this geometry. And it kind of works, because the office content, which is 1.5 million square feet, little more than that, has a central core and is designed for flexibility, so it can be subdivided in lots of different ways. You can see here from one of the construction shots, it was quite exciting. The diamond pattern is 54 meters high, and the noding out is over 8 meters, getting over between 8 and 9 meters high over 2 floors. So it's massively difficult. Plus the fact that nothing's vertical. The contractors had quite a challenge to achieve this, and they didn't. If it had been England, we'd have been harassed probably all the time. Every 5 minutes, the contractor would be asking us, how do you sort this out? But they didn't. They sorted it out mostly themselves, in discussion also with Arabs on the structure. But you can see it was a complicated piece of geometry. But it ends up as being a very simple building. And I should just mention that the horizontal strata that you can see relate to the plant and refuge floors, because there was a question earlier about plants. The fire officer wanted refuge at every 15 floors. They got them at every 16 floors. We have a double floor with plant and refuge, and that's part of the architecture. We've expressed that in the architecture of the building. Just to look at the hotel, and some of you would have stayed there last night, it's pretty exciting, that central space. Now, I can say that because I feel excited by it anyway. The fact that it's 34 meters high, it's got the glass atrium that opens out. It's open-sided most of the way up, but the fire officer wanted to enclose the top 8 floors in glass. So we created a sort of crystalline form, like a kaleidoscope, if you like, so that the light will bounce down into the space below. And this is as tall as St. Paul's Cathedral, the spire of St. Paul's. There's also a helicopter landing pad on the roof because the fire officer wanted evacuation from both the top and the bottom. And we said, well, what kind of helicopter will you be using? They said, we don't have a helicopter, but we want to be able to evacuate from the top. And I think it's a very good system. Fortunately, we haven't had to test it out yet. When the Four Seasons took over, they said, well, we like the design very much, but you've got to get rid of the columns because they're too big. And the columns are actually 1.9 meters at their biggest radius. They're steel tubes filled with concrete, and they go down to 900 at the top. And we said, well, if we do that, the building will collapse, and you better learn to live with it. So they did, actually, and they put in some more columns. So some of these are false columns. And actually, the feedback's been good, that people have been seen hugging the columns and adopting them as friends. So we as architects and engineers can learn something from that. Yeah, this is the crystalline glazing on the top floors. If you go to the bar tonight, that's on the 99th floor or 100th floor, that's what you'll see. And this idea of expressing the major elements of the building. Originally, we had a double skin facade, but it was value engineered out, which meant the glass got a bit darker, which is a shame. And of course, it's less efficient. But you can see that you can still see the structure, and it's lit up at night. And the plant floors are lit up in a different way. So we're going to move on to something completely different now. One of the advantages of designing a tall building is that you get on the list for other tall buildings. Oh, well, for competitions anyway. Very few people ever give you a project without a competition. And this was in Sydney, Crown Sydney, and it was an international competition, which we wouldn't normally expect to get on the list for, because it's a Barangaroo. It's one of the best sites in Sydney, overlooking, well, it's on Darling Harbour, and it's overlooking the Opera House and the bridge. So it's a pretty spectacular site next to 3 Richard Rogers buildings, and actually 2 Renzo Piano buildings are going in between as well. So we're in good company. And I knew the site because I'd spoken at a conference in Sydney a few years before, and I was desperate to win. Fortunately, when they were looking at the long list, they came to visit us, and they stopped off in Singapore in Gardens by the Bay, and they were very impressed with Gardens by the Bay. So they were inclined to, in our favour, if you like. And of course, we had to work hard, but we did get on the short list, and eventually we won the competition. So the geometry here is very different. I felt, and this was very much a personal thing, that it needed a sculptural form because of its incredible location and the fact that it was the last tall building in a run of tall buildings, and it needed to express itself in 3 dimensions. And it started, well, I should just say that the brief came out the day before we broke up for Christmas, and it was about that thick. I took it on holiday with me, and of course, it's a bad thing to do, as you know, as architects, because once it gets in your mind, you can't stop thinking about it. So I have a house in Italy, and I spent most of Christmas looking through the brief and getting to know it. And I was trying to work out how one could do something different with the tower, because basically all towers are pretty similar. They've got the vertical rise, a vertical shaft, and everything's hung off that. But I've been working on this sculpture for the borders between England and Scotland, which was just a piece of sculpture, and it had 3 petals that twisted as it rose up. And I thought, well, if you joined the tips of the petals together, you could create a building. such as, and the twist would be very interesting to deal with. But of course, we had to orientate the building so that it was looking mostly towards the Opera House and the bridge. So we changed the 90-degree twist to a 60-degree twist, and we bellied it out. But basically, that's the concept of three petals rising up. And as soon as I got back to the office, I said, we must, with some sketches, I said, can we just do some modelling quickly? I'm desperate to see whether it can work. And these were the first 3D parametric models. And I felt that there was mileage here and it was going to work. And we were all very excited with it. So we developed the idea. And of course, that leads to a lot of complications and in the development of the form. And I'm going to jump on now to, well, perhaps I just finished that the competition, the interview lasted 4 hours and there were about 12 people there. And I was tired anyway because I'd come from England. I had one of my partners with me. And I said to Paul Baker, I said, you look at them, I will talk, and you indicate to me if I've lost them, because I'm going to tell them a story. I'm not going to start with the plans and so on. And so I started talking about the petals, and these are, big, tough Australians. And I felt actually that I was getting somewhere, and the story went on, and they were sort of nodding. So anyway, it lasted 4 hours. We did talk about some of the details as well, but of course, when we got it, the reality of building this very complicated 3D form, it involves a central core with outriggers. But because the outside skin is all over the place, we had to develop these helical columns, which I'm not sure if they've been done before, but they're going to work with. We're working on the detail of that to create this complex 3D shape. And of course, the plans, I did have an animation which goes all the way up through, but didn't seem to be working, so I thought it was better to play safe. But you can see that each floor is very different. And the complications of that are where walls meet the outside wall, the internal walls meet the outside. It's very complicated. And apart from being on angles, they're tipped both ways, and they're in a different place. So it's actually very complicated. So you have to design every aspect on every floor. Anyway, we've gone through all of that, and we started on site. But before that, there was this other element where the client was very happy with the form, but he said, this is Crown Casino, resort casinos, and they said, we want it to be a bit more spectacular at the lower level. The podium, which is over 100 meters long, is what people see when they arrive. So can you come up with some ideas? So I thought about it, and these were two images I came up with, which was stone tracery. And I haven't, for some reason, I haven't got the sketch. I sent a sketch to Melbourne saying, how about this? Some stone tracery, Gothic stone tracery in Sydney. It'll be the first in marble. And they were back saying, yeah, we like it. If we can afford it, we'll do it. But then, of course, the problem is, how do you do stone tracery up to 28 meters high? I remember talking to Peter Rice about the idea of tensioning up stonework. Peter Rice was one of the greatest engineers of our time, who unfortunately died rather young. And fortunately, this is working with Arab's Facades. They had someone who worked on that project with Peter Rice, and this was the prototype, and this is what it's going to look like with this marble stone tracing. It's a kind of random pattern. It's not true Gothic, but there are some repeats. I think it's 14 repeats. And just to look at the tower, you can see where a tower meets the sky. It's very important. And our three petals go to the top, and you can see the petals expressing themselves at the top. The other thing I haven't had time to mention is that there's a lot of different, apart from the shape, there's a lot of different cladding systems. So where it's very curved, we've had to go for triangulations. Where it's straight, we've got some normal glazing, but the rest of it is some quite complex glazing systems, which are possible now and wouldn't have been 10 years ago. And we're out to tender on those glazing systems. So I'm going to move on now to Toronto in Canada. And the city is very, very interesting city, and it's got some beautiful museum towers there by Mies, which are very straight up and down. And all apart from that one, which is the Leapskin building, you can see to the left of our tower, they're all very straight up and down, vertical extrusions, and they made it very clear that they weren't going to consider anything other than a vertical extrusion. I think they'd had a look at our Sydney project and were a little bit scared by that. Again, it was an international competition, and we played safe. Just to give you a little bit of background, this is Bay Street, and Bay Street's a financial district of Toronto, but it's cut off from the lake by the railway. There are 8 or 9 tracks, railway tracks, and then there's a high-level road as well. And our client, big investors in the city, wanted to extend Bay Street towards the lake and bridge the railway. And this was what the competition was based on. We put towers on either side of the railway and linked them with a park. Initially it was with a shopping centre, but it didn't work out financially to have a shopping centre at high level, so we've got a park. And that's what we've been designing. You can see I should have waited till this light came up to show you where it is on Bay Street and how it bridges the railway. And it's quite a complicated thing to do. It involves a lot of investment and a lot of time and thought. And these are our towers that are on either side of the railway. And they're designed to step up from the lake so that you get the taller one or near the financial district. And the only difference, I would say, on our tower is the cladding. We thought there was an opportunity to do something different with the cladding, and we triangulated it and created some pyramids. Sorry, we're back on to the park across the railway. And the formal rectangular plan with central core, all very standard. The only difference is the cladding, which has a sort of pyramidal aspect to it. Now, by pushing the center of the pyramids out by as little as 800 millimeters, and it's changed over the years, but it's now 800 millimeters, you get this, it catches the light in a different way, and that's what we wanted, because we wanted it to sparkle on the skyline, and we carried it on so that there's a kind of crown at the top of it. And you can see how the two towers will have quite a big impact on the city, even though they're just straightforward, what I call straight up and down towers. And I'm just going to show an animation of the cladding system and of the outside of the building. I haven't got time to talk about the rest of it, but you can see it's all about light and the idea of catching light. And you know, you have to have a starting point when you're discussing this with hard-nosed businessmen. And it's surprising, actually, that you've got a hook to hang it on. It kind of works, and they're very excited by this project, and they love the idea of the park. And this is the view from the park along the railway. And I'm just going to finish now. I don't know how I'm doing on time. I'm going to, my last of 4 projects is in London. And you will have heard Eric Parry talking about his tower in the eastern cluster of the city, which will be the tallest building in London. We've got a much more difficult site on the edge on Leadenhall Street, next to the cheese grater, which is a Richard Rogers building, and next to a KPF-inspired building, which actually got stopped, and there's another story to that. But in London, we have very difficult planners and difficult sort of laws and regulations. It's also very congested, so we're fitting into a very tight space right in the center of the financial and insurance district. So you have to make use of every square inch, and you try to get the height where you can and the depth where you can. But it ends up with a variety of different things, because if you analyze the other tall buildings in the city, we found sort of 3 main intermediate heights plus the top ones, the tall ones that go above that. So you've got the traditional classical buildings at 60 meters. They're just sort of up to 5-6-story buildings, and they're classic. A lot of them are listed buildings. Then you've got the mid-level buildings, which were built some time ago, up to 100 meters. And then there's these sort of newer buildings, which include the Foster's Gherkin. That's 180 meters, and then there are a few going taller. So Eric's goes up to a little over 300 meters, and the Rogers cheese grater goes to about 220 to 130 meters. So there's a kind of levels which you can work within, and it's very constrained. We had our planning officer, because the cheese grater had only just finished, he was very pleased with it. And he says, I don't want you to go into the line, the diagonal line of the cheese grater, from a viewpoint behind St. Paul's Cathedral. So it's a kind of random thing, really, but it's set in law that there is this viewpoint on Fleet Street, which literally, if you moved 1 meter on either side, you get a completely different view. But everybody takes it from this one point, and we had to stay within the diagonal line of the cheese grater, which is, pretty absurd by anybody's thoughts, but we needed to get the permission. And I didn't want to step the building in a traditional way. I mean, that would be the easiest thing. We obviously couldn't take the same diagonal as Rogers, because having 2 diagonal faces would look absurd. So we were working on trying to get a stepped form, and this was the sketch that kind of did it for me, which was stacking some like boxes, really, rectangular boxes, stacking them on top, getting bigger as they go down, and trying to give each one its own identity. So this is how it works within the form, and some more sketches showing how it can change as it goes up. There was also a planning requirement to have a public space on the top floor with separate lifts and separate access. So working on this, we were trying to manipulate the form to create something interesting, which would, and of course one's limited to these 4 boxes, but by the top one is overhanging. So there's quite a big cantilever, which, again, working with Arabs, we had gave them a structural problem of how to support this tall building on top. And there's diagonal bracing on the outside, which we've expressed, and we've made the top floors much lighter and more transparent. So just looking at the plans, you can see that it's an awkward shape that we're left with, and there are lots of rights of light and things to deal with adjoining buildings. Some of these are listed buildings. We put the main lifts to the north, alongside what is a tall building, and they were threatening us, and we reciprocated by putting our lifts on that side. And I say threatening, I mean it's just we're being overshadowed by this huge building alongside. And we need a second lot of lifts to deal with the lower levels, but it's a big open plan. And what happens in this part of the city is that typically it's insurance, and they have brokers because it's very near Lloyd's, and they have a different way of life to us. They go into Lloyd's. They first of all go into their office, find out what they've got to insure. They go to Lloyd's, try and sell that. They come back and talk to their mates, and they have a sort of club actually where they all talk amongst themselves. But anyway, it's a different kind of way of life. So we had to design for them. They're on the upper part where the building's getting narrower. In other cities, people would say, well, it doesn't stack up. You can't have a small floor plate like that, 10,000 square foot. But in the City of London, you can, because the really big wheeler dealers, they don't need a lot of space. These are hedge fund managers. They just want a very nice space with a good view, and they're happy to pay any amount. I say that, but they'll pay very high rental for a space which they can fit out at high level. So it kind of works. And there we have the arrangement with some deep plan floors on the lower levels for the insurance market. And the hedge fund managers can all sit on top of each other on the high rise with the views. And again, just to go back to the differences, I mean, this is a very complex piece of geometry designed around some spurious constraints which we have in the city, because the City of London is very old. You know, we've got it goes back over 2,000 years, and we have to make it work. And it's exciting, you know, it's just as exciting and just as difficult and complicated to design a small building in an awkward, constrained site. So this is the view from at the top, the view from Fleet Street. Actually, this is from, I tell a lie, this is from St. Paul's Cathedral. It's the view looking east from St. Paul's Cathedral. And you can see how the cluster is beginning to form. And it's a little bit like this Guangzhou situation, where there's a lot of discussion, a lot of planning, a lot of thoughts go into how you get this cluster of tall buildings to work within the centre of the city and maintain the identity of London and improve the identity of it. So just to finish then, I've taken you on a whirlwind tour around the world, which is my life. But I think also it's important to think about geometry and form and how we as architects have this ability to influence the skyline. And I think once you stick your head above the parapet, as we say, you have to do something. You have a responsibility to design something that's beautiful, because people are going to have to look at it, not just now, but for the next generation and possibly the generation after them. I'll leave you with that to think about. Thank you very much.